today I just wanted to discuss briefly hurricane and windborne debris regions and how they're affected by the code. So basically, for glazing impact, it just basically says it has to be, tested with missiles. Well, those missiles are 2x4s that are typically launched in a testing apparatus at the structure to make sure everything works and doesn't blow out of the opening, doesn't allow anything from the exterior to get in. Hurricane-prone regions, they're just going to be the regions that are prone to seeing the wind speeds associated with hurricanes. It doesn't mean that they have to have, an impact-rated system within that zone. There is, as you'll see coming up, a limit to the speed to where you have to have impact-rated systems. So for this, for a Category 2 building, anything that's greater than 115 miles an hour, that's going to be considered your hurricane-prone region for 710. Just to give you an idea on a map, anywhere that you see this like orange color, that is the 115 mile per hour line. So from that to the Gulf, to the Atlantic, that's going to be your hurricane-prone regions, according to ASCE 710. So diving a little bit deeper, there's a section in Chapter 26 that deals with windborne debris regions. And they kind of talk more in depth about what that is. Well, if you're within 1 mile of the coastal mean water line for the ocean or the Gulf, or it's greater than 130 miles per hour, it has to be an impact-rated system. This also includes areas where the wind speed is greater than 140 miles an hour. Now, there is a little note underneath of it that is highly important for us to understand. For a risk category 2 building and structures and risk category 3 buildings and structures, except those that are healthcare facilities, we're supposed to use the category 2 maps to determine the wind speed to get your requirements for an impact rated system being needed or not. So once again, we'll look at that map. So 140 miles an hour is, the limit to where you do need to have an impact rated system or protective glazing. For a risk category 2 building, any of them, and any risk category 3 buildings excluding healthcare facilities. So that's what that map looks like. And this is all on the server and the lessons learned if you need to pop it up just to look at it. And then for a risk category 3 healthcare facility and all risk category 4, we're using the risk category 3 wind maps to get that 140 mile per hour line. And you see that more of the inland coast is affected and requires impact rated system and glazing. 716 basically has the exact same wording for glazing impact for the hurricane prone regions. Very similar maps, slightly different just due to the new updated wind speed contours of the map and whatnot. So you get a little bit different, more inland in 716. The same wording is under in Chapter 26, the windborne debris regions, as it is in 710. It reads the exact same. It's just the maps that are changing. So for 716, you get more inland requirements for that risk category 2, and then risk category 3 buildings excluding healthcare, you get more inland, and even more inland for the risk category 3 healthcare facilities and all risk category 4 buildings. And then here's the risk category 4. So I just wanted to make everybody aware, the requirements for what we need, what the maps actually look like for the regions that are considered hurricane prone versus those that are require impact systems. And if you've never seen one of the impact testing stuff, I found a good little video because, I think it was 2 weeks ago, some of us sat in on a Texas Department of Insurance presentation, and they kind of indicated in that presentation that you don't necessarily have to have a laminated IGU. There are other means to protecting the glazing, and this kind of goes into some of them, and you can kind of see the pros and cons of them.
Now, this is a testing facility, and it's not really open to the public, but I thought it would be a great place to show you all of the options that there are when covering your windows and doors during a hurricane. And to do that, we're actually going to use this right here. This is actually a cannon that will fire a 2x4 at all of those options and show you how they hold up. It will fire a 2x4 at 34 miles an hour at a window or door.
Wow, a cannon, Tommy? Why 34 miles an hour?
Well, 34 miles an hour, even though the winds of a hurricane may exceed 100 miles an hour, that's the speed that an object is picked up and thrown through the air, like a trash barrel or a tree limb, or in this case, a 2x4, pick it up and throw it through the air at those doors and windows at 34 miles an hour. Now, in most cases, you see people boarding up their windows and doors using plywood. Now, it's important that the plywood is cut to fit the opening, and the building code says that that plywood has to be a minimum of 5/8 of an inch thick. Now, that 5/8 of an inch thick plywood is $30 a sheet. Now, as a homeowner, you may go to the lumberyard or home center and say, well, gee, I can get a sheet of 1/2-inch OSB. It's $10 a sheet and save some money.
Well, that's what I want to do. I want to save a few bucks.
Well, okay, cheapskate, let's see what happens. Okay, here we go. You can see the cannon is aimed at the OSB. You can see the red laser. That's where it's going to hit it. Wow! That 2x4 went right through the OSB and through the window. Looks like you're going to have to get a new window.
Wow, I didn't save any money there.
You sure didn't. Let's see what happens with the 5/8 plywood now. Oh, the plywood did its job, and the 2x4 bounced right off of it, and the window is still in good shape behind it.
It's remarkable how the plywood held up better than the OSB.
Well, the plywood is much stronger, and let me show you. The plywood is actually different laminates, and the laminates run in different angles. There's long strands that run this way, another one that runs this way, and so on down the line, and that's what gives it a lot of strength, along with the thickness. Now, OSB, or oriented strand board, are actually small pieces of wood that are actually glued and put together, and it's not strong enough to withstand that force.
Now, I know the 5/8 plywood did its job. That's pretty heavy to lug up to my second floor window. Do you have any other alternatives?
We sure do, and let me show you some. Over on this wall, we set up some windows. This window we covered with this fabric right here. It's a ballistic nylon treated with resins, and it's really strong. It's held on the building using these brackets right here and these fasteners that stay on the building all the time.
Well, this thin piece of nylon is going to protect my window?
I don't know. Let's test it and find out.
Wow, Tommy, what happened?
Well, Paul, the fabric did its job, and the 2x4 didn't enter the building. And in many jurisdictions, that's acceptable by the building code.
Yeah, but the window broke.
Right, and we installed the fabric as per the manufacturers. But it is a fabric, and it does have some deflection. So under these conditions, when the 2x4 hit the fabric, it deflected enough for the 2x4 to break the window. Now, both the plywood and the fabric have to be installed onto the building every time there is a storm coming. This is a metal shutter that's permanently installed on the exterior of the building. You may have to get up onto a ladder to close it and lock it. They do have metal shutters that you can operate from the inside, and even some that operate remotely.
Remotely? Let's give it a test.
Okay. Whoa! The window broke on that one.
Tommy, what happened? Another broken window?
Well, here in the test lab, they have to aim the cannon so it hits in the center of the shutter. In this case, it hit in the center of the shutter exactly where the lock is, bending the shutter, snapping the lock, opening the shutter. Now, all of the systems that we have looked at already are actually called active, which means you have to do something to protect your window. This is a passive system right here. That means you don't have to do anything. It's built into the system. It has impact glass. It's an insulated window. Now, the outside layer of glass is actually 2 layers of glass. And in between those 2 layers of glass is sandwiched this membrane right here. So if a flying object should hit your window, it will shatter like a car window, but you won't get a hole in it.
Well, let's test it out.
Okay. Whoa! Well, it broke the glass, but no hole. And your house is still protected against wind and rain.
This is great. Thank you, Tommy, for showing me all these options.
Yeah, so ultimately, most of the people that we deal with are going to, have the laminated, insulated glass, and the laminate is on the inboard pane of glass, usually.
Okay, so talking about hurricane zones, that's actually a really good kind of primer for one of the things I was going to talk about today too. So just to kind of add to what Kyle was talking about hurricane zones, if you guys don't have this AT Council hazards by location map saved somewhere, I would highly recommend you bookmark this and use it, because it gives you maps for the wind speeds based on your location. It also does snow and seismic if you need to verify based on like what's in structural drawings. And based on the location of your project, it actually tags your windborne debris regions and all of the stuff that Kyle talked about as kind of an easy summary on what needs to be included, what doesn't. So that's very helpful to make sure you're actually using the correct, is it impact rated, is it not? And then there's also exceptions for like the city of Houston that they define their wind speed as 139. So there are some hairy sections of the city that are around this 140 line that may look like they need to be rated, but they're not per the city. So those are some of the things you need to be very, very careful about in these impact hurricane regions. Over in Florida, it's going to be the same thing. There's some places on like eastern Orlando that start getting really close to that line. And sometimes the structural drawings will use 140. Sometimes they'll really push it and back it down to 139, so it's not impact rated, to avoid that cost and stuff. So just pay very, very close attention to that. And if there's ever any questions, come bug me or Matt that have dealt with this more, so we can kind of point you in the right direction. So both the AT website and there's the ASCE 7 tool that it isn't quite as good about marking what's impacted and stuff, but both of those are really useful.